Every single day in Australia, tens of thousands of cattle move across landscapes so vast they are larger than entire cities, spreading out over millions of acres where fences are few, humans are scarce, and yet nothing is random. Nothing is uncontrolled, and nothing is wasted. Because behind this seemingly natural system is one of the most precisely managed meat production networks on Earth. A system that processes up to 9.1 million cattle every year while maintaining consistent quality, strict traceability, and global supply reliability at a scale most countries cannot even attempt. And here's what makes it even more unusual. Australia does not even have the largest cattle herd in the world. Not even close, with around 30 million head compared to Brazil's nearly 190 million. Yet it consistently ranks among the most trusted and efficient beef exporters globally. Which raises a critical question. How does a country with fewer animals, harsher climates, and extreme distances manage to outperform larger competitors in efficiency? Consistency and global reach. The answer begins far away from factories and processing lines. In remote regions where cattle are not confined, not force-fed, and not constantly supervised, instead they grow across open land under conditions that would normally reduce productivity, extreme heat, limited water, and unpredictable drought cycles, yet somehow this environment becomes an advantage rather than a limitation. Because instead of forcing cattle into artificial systems, Australian farmers build a model that works with natural behavior, allowing animals to move freely, search for food, and adapt to conditions, while every critical variable is still monitored, tracked, and optimized in the background. And this is where the scale becomes difficult to comprehend. Some single ranches manage between 10,000 to 50,000 cattle across areas so large that traditional farming methods completely fail. You cannot rely on fences alone. You cannot monitor animals manually, and you cannot react slowly when conditions change, because a delay here does not affect dozens of animals, it affects thousands. Which means the entire system must operate with speed, coordination, and accuracy at all times. And yet, when viewed from above, it looks almost empty. Cattle scattered across massive land, moving slowly, grazing quietly. No visible signs of industrial pressure. But this calm surface hides a highly structured network where every animal is part of a larger flow, from birth to growth, from pasture to processing. From local ranch to international markets, and the most important part is this. The system is designed not to maximize short-term output, but to maintain long-term efficiency across unpredictable conditions. Which is why instead of pushing cattle to grow faster at any cost, the entire process is built around balance, letting nature handle growth while humans control timing, movement, and decision-making. And this approach creates something extremely rare in modern agriculture. A production system that is both massive and stable, capable of scaling across millions of animals without collapsing under its own complexity. But this still does not explain the full picture, because managing cattle across open land is only the first layer. What happens next is where the real transformation begins. Once these animals leave the pasture, they enter a completely different world. One defined by speed, precision, and industrial processing, where tons of meat are handled every hour, where machines slice, cure, cook, and package products in continuous lines, and where every step is optimized for efficiency without breaking the chain of quality control. And this is where the system reveals its true nature. It is not just farming. It is not just processing. It is a fully integrated supply chain where biology, technology, and logistics are synchronized at a national scale. And understanding how this system actually works requires breaking it down step by step. Starting from the very beginning, where every decision determines whether the entire chain will succeed or fail. Australia's position in the global beef industry looks unusual. At first glance, because it does not rely on having the largest cattle population. Instead, it relies on building one of the most controlled and efficient livestock systems ever implemented at a national scale. With around 30 million head of cattle distributed across regions like Queensland, New South Wales, Northern Territory, and Western Australia, where environmental conditions are not ideal, but extremely challenging. Long dry seasons, high temperatures, and vast distances between water sources. Conditions that would normally reduce productivity in most livestock systems. Yet here they are used as a filter to shape a more resilient and cost-efficient model. Because instead of trying to eliminate these environmental pressures, Australian producers design their entire system around them, starting with breed selection, where only cattle that can survive, adapt, and grow under heat stress and limited resources are chosen. Breeds like Brahman, Angus, and Hereford are carefully engineered crossbreeds that combine heat tolerance with consistent weight gain. Animals that can walk several kilometers daily without losing condition, maintain feed efficiency under stress, and still meet strict market requirements. And this is where the system begins to separate itself from conventional high-input livestock models. Because rather than maximizing growth through heavy feeding and confinement, the goal here is to minimize intervention while maintaining predictable outcomes, which requires precision at the biological level from the very beginning. Especially during the breeding phase, where every cow represents a long-term investment. With a pregnancy cycle of roughly 283 days, meaning nearly a full year of resource allocation before a single calf is produced, and at this scale, inefficiency cannot be tolerated. So farmers implement strict selection criteria where only cows with strong skeletal structure, proven reproductive performance, and resistance to disease are retained in the breeding herd, while those that fail to conceive within a defined window are removed or reassigned, not as a loss, but as a strategic adjustment to maintain system efficiency. And this is where the numbers become critical, because on large Australian ranches, achieving an 85 to 95% pregnancy rate is not just a target. It is a requirement to sustain output without increasing costs. And maintaining this level of performance under natural grazing conditions requires constant monitoring, not through continuous human presence, but through scheduled inspections, data tracking, and environmental observation, ensuring that pregnant cows receive sufficient nutrition from natural pastures supplemented with minerals when necessary, preventing weight loss during extreme heat, and maintaining mobility so that they can continue to forage effectively. And once calves are born, the system shifts into its next phase, where one of the most important principles is applied: minimal confinement. Instead of being raised in enclosed facilities, calves remain on open pasture alongside their mothers, learning movement patterns, grazing behavior. An environmental adaptation from the earliest stage, which reduces stress, lowers disease risk, and significantly cuts down the need for antibiotics, creating a healthier animal with lower long-term management costs. But this natural approach does not mean a lack of control, because every calf is immediately integrated into a national tracking system through the National Livestock Identification System, where an electronic ear tag is assigned shortly after birth, recording critical data such as origin, breed, sex, vaccination history, and movement across different locations, transforming each animal into a traceable unit within a much larger network. And this level of traceability is not optional, it is mandatory, forming the backbone of Australia's ability to guarantee product origin and safety to international markets. And as calves grow and reach weaning age at around 6 to 8 months, typically weighing between 180 to 250 kilograms, they transition into a rapid growth phase where the system continues to rely primarily on natural pasture rather than imported feed, which significantly reduces operational costs but introduces a new layer of complexity, because pasture itself becomes a managed resource that must be controlled with precision. Land is divided into multiple paddocks, and cattle are rotated strategically to prevent overgrazing, allowing grass to recover and maintain nutritional value. And in cases where land is depleted, entire sections are left unused for extended periods, even if it means temporarily reducing stocking density, because long-term productivity always outweighs short-term gain. And this is where water infrastructure becomes another critical component. Especially in arid regions where natural water sources are scarce, farmers build extensive systems of wells, reservoirs, and artificial tanks spaced across large distances, forcing cattle to move regularly between grazing and watering points, sometimes walking for hours each day. And while this may appear inefficient at first, it actually contributes to stronger muscle development and more consistent fat distribution, directly influencing meat quality. And at this stage, the system reveals a key principle. Nothing is optimized in isolation. Every decision, from breed selection to grazing patterns to water placement, is part of a coordinated structure designed to balance cost, animal health, and product quality. But even with this level of planning, scale introduces a new challenge because managing thousands of animals across such vast land cannot rely on traditional methods alone. And this is where the system begins to evolve beyond farming into something far more complex. At this point, the system stops looking like traditional agriculture and starts operating more like a distributed control network. Because once cattle are spread across tens of thousands of acres, often in herds ranging from 10,000 to over 50,000 animals, direct human management becomes physically impossible, and any delay in detecting problems such as injury, disease, or a resource imbalance can quickly escalate into losses affecting hundreds or even thousands of cattle. Which is why Australian ranches rely on a layered control system that combines trained animals, mechanical mobility, and real-time data monitoring to maintain stability across extreme distances. And one of the most underestimated components of this system is the use of herding dogs, especially breeds like Kelpies and Australian cattle dogs, which are not just helpers, but highly trained operational assets capable of running dozens of kilometers per day, responding to subtle commands, and independently controlling cattle movement patterns, preventing herd fragmentation and guiding animals toward designated zones for inspection or relocation. And when combined with horses and all-terrain vehicles, this creates a mobile control layer that allows a small number of workers to influence the behavior of thousands of animals across terrain that would otherwise take hours or days to traverse on foot. But even this is not enough at the highest scale, because visual coverage remains limited. This is where aerial control becomes critical, with drones now being deployed to scan large areas in minutes, identifying cattle that have strayed, detecting unusual movement patterns, and monitoring pasture conditions such as overgrazing or vegetation decline. While in even larger operations, helicopters are used for rapid intervention, capable of redirecting entire sections of a herd within a short time frame, effectively compressing what would be hours of groundwork into a fraction of the time. And when these aerial tools are combined with satellite data, farmers gain a macro-level view of their entire operation, allowing them to track seasonal changes, predict feed availability, and make proactive decisions rather than reactive ones. And this is where the system reaches a new level of efficiency. Because instead of constantly managing problems, it begins to anticipate them, adjusting cattle distribution, grazing intensity, and resource allocation before imbalances occur. But despite this high level of control, the environment remains the most unpredictable variable, and drought stands as the single greatest threat to the entire system. Because when rainfall drops and pasture dries out, the natural foundation of the model collapses, forcing farmers into rapid decision-making scenarios where they must either reduce herd size or import feed at extremely high cost, both of which directly impact profitability. And historical drought periods have shown that even a well-optimized system can contract quickly under sustained environmental pressure, with herd numbers declining significantly before recovering in more favorable seasons. And this constant exposure to environmental risk is what drives the system to remain flexible, never overcommitting resources, always maintaining the ability to scale down and recover. But drought is not the only threat, because predators also operate within this landscape, particularly dingoes, feral dog hybrids, and foxes that target vulnerable calves, especially during the first few months of life when they are most at risk, typically attacking during low visibility periods such as night or early morning, which forces ranchers to implement protective strategies including controlled breeding timing, herd grouping, and increased monitoring during high-risk periods. And all of these factors together reveal a critical truth about the system. It is not designed for maximum output under perfect conditions. It is designed for survival and consistency under imperfect ones, where every component, from animal genetics to land management to technology integration, contributes to maintaining balance across a constantly shifting environment. And this balance is what allows the system to operate at scale without collapsing, but it also sets the stage for the next phase. Because once cattle reach the right age and weight, the entire process transitions from decentralized control across open land into a tightly coordinated industrial pipeline where speed, precision, and volume reach an entirely different level. When cattle reach the critical threshold of 18 to 24 months and weigh between 450 to 600 kilograms, the entire system shifts from slow, distributed growth into a tightly controlled movement phase, where timing becomes everything. Because at this stage, every delay reduces value, and every inefficiency multiplies across thousands of animals. And this is where the decentralized ranch system connects directly into a centralized processing pipeline. Beginning with the gathering phase, where cattle that have spent their entire lives across open pasture are brought together into holding areas using coordinated efforts between dogs, riders, vehicles, and sometimes aerial support, compressing vast distances into controlled zones where animals can be inspected, sorted, and prepared for transport. And even here, the system maintains strict protocols because stress at this stage can directly impact meat quality. So cattle are held for a minimum of 24 hours to stabilize, recover from movement, and normalize physiological conditions before entering transport. And once cleared, they are loaded onto specialized livestock trucks designed with ventilation systems, non-slip flooring, and carefully calculated density to prevent injury during long-distance travel. Because unlike small-scale operations, these transport routes can span hundreds or even thousands of kilometers, linking remote ranches to high-capacity processing facilities. And this is where the system accelerates rapidly. Because once cattle arrive at processing plants, the entire operation transitions into an industrial environment optimized for continuous flow, where every stage is synchronized to handle large volumes without interruption. And unlike the slow rhythm of pasture life, processing facilities operate on strict schedules where animals are moved through sequential stages with minimal downtime, starting with humane stunning methods that render cattle unconscious instantly to reduce stress and meet strict welfare standards, required for both domestic and international markets, followed by rapid processing lines where carcasses are cleaned, inspected, and broken down into primary cuts such as tenderloin, ribs, shoulder, and leg, all within a controlled environment designed to maintain hygiene, speed, and consistency. And this is where scale becomes visible in a completely different way. Because instead of thousands of animals spread across land, the system now handles large volumes per hour within a confined space, using specialized equipment to process, chill, and prepare meat for further distribution. And immediately after breakdown, the meat enters rapid chilling systems to bring temperatures down quickly, preventing bacterial growth and preserving texture, before being routed into cutting and packaging lines where precision machines divide products into standardized portions, vacuum seal them, and label each unit with traceability codes linked back to the original animal, ensuring that every piece of meat can be tracked through the entire supply chain. And from here, the system branches into multiple product pathways, because not all meat follows the same route. Some remains as fresh cuts for premium markets, while others are directed into secondary processing lines where the transformation becomes even more intensive, feeding into industries that produce bacon, ham, sausage, jerky, canned meat, and other processed products at massive scale. And inside these facilities, speed and volume increase even further, with grinders processing tons of meat per hour, slicers operating at high speed to produce uniform cuts, curing systems injecting solutions directly into meat fibers in seconds, and cooking chambers capable of completing processes in hours that once required days, all coordinated in continuous production lines that minimize downtime and maximize output. And this is where the system reveals its full integration, because the same animal that moved across open pasture months earlier is now part of a high-speed industrial chain where nothing is wasted. Every component is utilized, and every output is directed toward a specific market demand and beyond domestic consumption. A significant portion of this production is prepared for export, packed under strict standards that meet requirements from countries such as the United States, Japan, South Korea, and China, where traceability, quality, and safety are non-negotiable. And this export system operates alongside another complex channel, the live cattle trade, where hundreds of thousands of animals are transported directly to international markets such as Indonesia, Vietnam, Malaysia, and regions in the Middle East, using specialized livestock ships equipped to maintain animal welfare over long journeys, and in some cases, even air transport for high-value breeding stock. And this dual-channel system further increases the complexity of operations because it requires maintaining standards not only within domestic facilities, but also across international logistics chains. And as a result, strict regulations are enforced to monitor animal welfare, transport conditions, and slaughter practices even after cattle leave Australian territory, making this one of the most tightly controlled livestock export systems in the world. And at this stage, the full scale becomes undeniable, because what began as scattered animals across vast landscapes has now transformed into a synchronized industrial network capable of moving, processing, distributing millions of cattle every year with remarkable consistency. But even with this level of efficiency, the system is still not complete, because its long-term success depends on something far more complex than speed and scale alone. At the peak of this system, everything converges into a continuous industrial flow, where speed, precision, and volume are pushed to levels that most people never see. Because once the carcasses leave the primary processing line, the transformation does not slow down, it accelerates, splitting into multiple parallel production streams, where different parts of the animal are directed toward entirely different product systems, each optimized for a specific market. And this is where the true scale of processing becomes visible, not in the number of cattle, but in how completely each animal is converted into usable output, because nothing is left idle. High-value cuts are routed toward premium fresh markets, while the remaining portions are fed into secondary processing lines that operate almost like factories within factories, producing bacon, ham, sausages, jerky, canned meat, and dozens of other products simultaneously and inside these facilities. The pace is relentless. Meat blocks are fed into industrial grinders capable of processing multiple tons per hour, breaking down large volumes into uniform mixtures that can be precisely controlled for fat ratio and texture. And from there, the material moves into high-speed mixing systems where salt, spices, and curing agents are added in exact proportions, not by estimation, but by calibrated systems designed to ensure consistency across thousands of batches. And once blended, the product is pushed into forming machines that operate at extreme speed, slicing, shaping, or stuffing depending on the final product, creating uniform outputs whether it is thin slices of bacon, perfectly cylindrical sausages, or evenly sized meat portions. And the efficiency here is not just about speed. It is about synchronization, because every machine in the line must match the output of the previous stage, preventing bottlenecks and maintaining a constant flow. And this is why modern facilities rely heavily on automation, where conveyors, sensors, and control systems continuously adjust operations in real time, ensuring that throughput remains stable even under fluctuating input volumes. And one of the most striking examples of this efficiency is seen in curing and cooking processes, where traditional methods that once required days have been reduced to hours through the use of controlled environments, injection systems, and convection ovens, allowing large batches of product to be processed quickly without sacrificing flavor or texture. And after cooking, the system immediately transitions into rapid cooling phases where temperature is brought down quickly to stabilize the product and prevent bacterial growth, followed by slicing machines that can produce hundreds of uniform pieces per minute, each identical in thickness and weight, and then into packaging lines where vacuum sealing removes air, extends shelf life, and prepares the product for long-distance transport. And at this stage, the system is no longer dealing with individual animals. It is handling standardized units of food, moving through a global distribution network. And this is where traceability remains critical, because every package carries data that links it back to its origin, ensuring that even at this scale, quality control is never lost. And beyond processed meats, the system also handles preservation-based products such as jerky, where lean cuts are sliced, marinated, and dried until they lose a significant portion of their original weight, sometimes over 70%, concentrating flavor while extending shelf life to months without refrigeration, or canned products where meat is sealed, sterilized, stored in conditions that allow it to remain safe for extended periods, making it suitable for export to distant markets where cold chain logistics may be limited. And across all these product lines, One principle remains constant: maximum utilization, because the system is designed to extract value from every part of the animal, reducing waste to the lowest possible level, while increasing the number of products that can be generated from a single input. And when this process is scaled across millions of cattle per year, the output becomes enormous, producing millions of tons of meat products that are distributed across domestic and international markets. And this is where the system connects back to the global stage. Because countries such as the United States, Japan, South Korea, and China rely on these consistent supply chains to meet demand, importing large volumes of beef products that meet strict standards for safety, traceability, and quality. And this demand is what drives the entire system forward, because it creates a constant pull that requires the network to operate without interruption, maintaining output levels regardless of seasonal changes or environmental pressures. And at this point, the system has achieved something that is extremely difficult in agriculture. It has turned a biological process that is inherently slow and variable into an industrial operation that is predictable, scalable, and globally integrated. But reaching this level introduces a new question, because when a system becomes this large and this efficient, the challenge is no longer how to grow it, but how to sustain it without breaking the balance that made it successful in the first place. At the final stage, the full picture becomes clear, because what Australia has built is not just a cattle industry, but a highly coordinated system that connects land, biology, technology, and global logistics into a single, continuous operation capable of producing millions of tons of beef every year, while maintaining consistency under conditions that would disrupt most other systems, generating tens of billions of dollars annually and supporting entire supply chains that stretch far beyond its borders. But the real strength of this system is not only in its scale, it is in its ability to remain stable under pressure, because every component has been designed with flexibility in mind. From herd management strategies that can expand or contract depending on rainfall, to grazing systems that allow land to recover, to processing networks that can adjust output based on market demand. And this adaptability is what allows the system to survive repeated challenges such as drought cycles, fluctuating global prices, changing consumer expectations. And yet, this same scale also introduces new levels of complexity and responsibility. Because as production increases, so do the questions surrounding sustainability, environmental impact, and animal welfare, especially in areas such as long-distance live cattle transport and large-scale industrial processing, where maintaining standards across thousands of kilometers in multiple countries requires constant monitoring and strict regulation. And this is why the system continues to evolve, integrating new technologies, improving traceability systems, and refining operational practices to meet both economic and ethical expectations. And at the same time, global demand for meat continues to rise, with hundreds of millions of tons consumed each year, creating ongoing pressure to increase efficiency without compromising quality. Which means the future of this system will depend on how well it can balance productivity with sustainability, maintaining output while reducing environmental impact and ensuring responsible treatment of animals. And this is where the bigger picture emerges. Because the Australian model demonstrates that large-scale agriculture does not have to rely solely on intensive confinement or excessive resource input, but can instead operate by aligning natural processes with human control systems, creating a structure that is both efficient and resilient. And as this model continues to develop, it raises a critical question that extends far beyond one country or one industry. What should the next stage of food production prioritize? Maximum output to meet growing demand, or long-term sustainability to protect the systems that make that production possible? And understanding how this balance is achieved may ultimately determine not just the future of Australia's cattle industry, but the future of global meat production itself.